Hello Regina Sailing family and friends. Let's do a little short episode of a compass check which should be done every time you are doing a sunshot, because it is such a nice spin-off. So this time we do not need the nautical almanac, so we can take this beloved book away and instead look at one of our shots that we have made. Here, this was a shot we made on approximate position, latitude 14 degrees and longitude 52. Where the heck is that? Well, I have a little piece of paper here. This is one of my very nice charts which I like using when I hear weather forecasts about with lows and highs situated on the Atlantic somewhere, and then you can, while listening to these on the SSB or so, you can then just draw in, or you can also mark your friends where they are when they give their positions. It's very approximate. You have the longitudes down here and the latitudes there. So on our position 14 north, 52 west, so 14 north, that's about here, and 50, that's 55, 52 west, that's about here. So that's where we are on our westerly course towards the Caribbean. And this, we made a morning shot. You might remember it was 11:45 UTC, so that was quite early in the morning. So that means that is when we shot the sun, which is good because the sun is then somewhere around here. And if you want to know it more precisely, you can see there is the spin-off. We have the azimuth of 124 degrees. So the azimuth is direction of the sun. It's here somewhere. So the sun is there. Here is our boat. And then we have our hardtop and our dodger, which prevents the sun shining from, in this case now, westerly direction. So it's perfect. So it shines here from the back of the boat, and it gives a nice shadow on the compass. So this is what we're going to do. So we will have a shadow. So first of all, we have to note the heading. So I had a course here, course over ground 271, but that's not the important thing, because the important thing here is the heading, because what we want to have is a deviation table. Others, they collect stamps, I collect courses. So we have a course here, and then we want to have a deviation here. So there we want to write a course and collect these, and in the end you have a lot of nice courses, and then you can make your own deviation table. So this course, this heading, because that's important, you read off that the needle on the compass, you look, and we say that we have a heading of 256 degrees compass. So that is the heading of the boat. Never mind the course. The course over ground can be 271 degrees. That's over ground with variation and deviation and all sorts of things taken into account, current maybe. But when we do this compass check, let's say that we had a heading of 256 degrees and we want to know what's the deviation here. And then we see this shadow. So in the middle of the needle, you can, I don't have a picture. I would have loved to give you a nice picture of this, but I'll see if I can take one on Regina Alaska next time. So if you look over the needle in the middle, and then it gives a shadow. Here is the sun is over here. There is the sun. But on this side, it gives a nice shadow on the opposite side of the needle. And here is the compass rose, north, south, or I don't know where we are. So this is the shadow that we can read off. And the shadow in this situation, we say we had a shadow of 370 degrees on the compass, of course, because that is also something that we read off here. So we now know that the shadow on the compass is 317 degrees. As a side effect, we also know here that we have an azimuth of 124. So the Zn, the azimuth, is 124 degrees true, because the azimuth that we get out of the books is always true. So we can't change that. Which shadow would this azimuth have given on the compass if there had been no other corrections to be made? Well, it's the reciprocal of that, isn't it? So here you have to see what is the opposite side of 124. And there are various ways to do it: add 180, subtract 180. But from the time of flying, I had a very good way of doing it, and this is a little trick, because what you really do is you add 200 and subtract 20, or you subtract 200 and add 20, whatever suits you. So that means that the trick to give a reciprocal very quickly on a figure, on a course, is to keep the last figure here. We keep the 4, and then what we do is that we look at these two digits. Here, one of them we add 2 and the other one we subtract 2. So what makes most sense is that we add 2 here, so that's a 3 plus 2, and then minus 2 here, so that is minus 2, that makes 304. So 304 would be the shadow that the needle should give. It gave 317, but it should have given the 304. If you didn't follow this trick with plus 2 there and minus 2 there, just do like this. Take 124 degrees, add 180, and then you add these together and it becomes 304. It's the same thing. So very nice. So now we use these wonderful little phrase that true virgins make dull companions. So that is the true, and then we have the variation, and then we have the magnetic course, and then we have the deviation. That's the one that we are looking for, and then we have the compass. So the true that the shadow should be is 304. So we can write this here, 304 degrees true, because that we can't change. The variation we also know. So that's why it's good to know a little bit where we are. And here you can see that we are just south of this tip of Newfoundland there. And you can look in your variation table or look at the isogones. So this, I've put this on 2020, so that's always good to have on the boat. This green line is 0 degrees variation. The red ones on easterly, these are westerly variations. And every one of these lines is 2 degrees. So we have here 0 degrees across the English Channel here approximately, 2 degrees westerly variation in Wales, 4 degrees westerly variation west coast of Ireland. So that's 2, 4, 6, 8, 10. So that's a thick line. So we have 10 degrees variation over here. And that goes past the Azores and the actually Cape Verdes here. So that's 10. But we are south of Newfoundland here and just east of the Caribbean here. So that is where we are. So what is the variation here? So it's 10, 12, 14, 16, that's 17 degrees. And that makes this a bit, 17 degrees west, that makes this exercise a bit special because we have such a huge variation there. So that's fun. So 17 west, so we have 17 west, we can't do anything about that. And since we have now the true course of the sun, of the azimuth, and the variation, we can say that from here in this direction, west is best. That means we add, and east is least. So from there we add the 17. So that means we get some 321. So that is 304 plus the 17 makes 321 the magnetic. So what shadow did we have? Well, the shadow we did have was 317. So we can write that here, 317 compass. So now what's the difference here? So from 321, to get from 321 to 317, we actually have to deduct a figure, right? So we have to deduct 4 degrees here. And since west is best, east is least, and that's the deducting. So here from there to there we have 4 east. So now we know that when we have 304 degrees, the reciprocal of the true azimuth, we know the variation, that means that we get a magnetic course. We know the compass shadow, because that's what we have read on the compass. So then the difference between those two is minus 4 degrees east. So it's easterly deviation. Now this deviation is only valid for our current course, or our current heading, better. So our heading is 256 degrees. So here we can write 4 east. So this is a very nice little exercise. It's so simple really that all you have to do is that you take the reciprocal, and it doesn't really matter if you take the reciprocal of the azimuth as I did, or some people do the reciprocal of the shadow. Because if you take the reciprocal of the shadow, 317 degrees here, you can take the reciprocal, that goes very quickly. You take the 2 less in the first digit, that puts it to 1, and here you add 2 in the second, that makes it 3, and you leave the 7 there. So that means that the shadow tells you that the sun should be in a compass direction of 137. So you could also do it that way, that you have the reciprocal here. Let's just do that. So we say 137 degrees is the compass that the compass or the shadow suggests that the azimuth is. But then you're not allowed to do the reciprocal here. So we have the Zn, the 124 degrees true there. We of course have the 17 west, so that means that we have to add these two here. So that becomes 141. And then we have the difference between 141 magnetic here and the 137 compass there. So to get from 141 to 137, that's of course also 4 east. So it doesn't matter if you take the reciprocal of the azimuth and then compare it with the shade, or you do the reciprocal on the shade and compare it with the azimuth. It's the same thing, but what is very important to remember, and that some people forget, is that when is this valid? It has nothing to do with these, because the deviation will always remain the same on this heading, irrespectively of where the sun is. That makes sense. So in the evening, when you have a totally different azimuth and totally different shadow, you still have a deviation of 4 east if you continue on this heading. So I hope you found this of interest, how you just get this as a spin-off. I really like doing this. And it's fun. Even if you don't do a celestial shooting of a body, you can just quickly calculate your azimuth when you have a good shadow on your compass, and then compare it to your existing deviation table. And if you don't have one, make your own. Well, thank you for listening in all these courses. I'm really proud if you've come this far. Well, see you maybe in Malta on a real course, or why not sailing on Regina Lasca together.